Okay, so what we're going to do in this next video is we're going to work with exponents, but we are really going to explore a few different subjects within exponents. Now, for now, we're actually going to leave out variables because variables can really confuse the subject, but we have to start with some basics. In fact, everything we're going to do in this particular set of videos is going to be basics. And we're going to start with some basics. So for example, there are some values that you must have memorized for college algebra. For example, 2 squared, or 2 to the second power. We know that this means 2 times 2, right? Because it's got an exponent of 2 and a base of 2. So it's saying include the base 2 twice in a multiplication problem. So we know that this is going to be 2 times 2 times 1. Now remember, this times 1 really is just sort of, I don't know, incidental, okay? We just need to remember that we're always, anytime we're doing a product, we're always multiplying by 1. It's just lingering there, okay? But really we're focused on the 2 times 2. 2 times 2 is 4, 4 times 1 is 4, so we know that 2 squared is equal to 4, and that has to be just a normal memorized thing in your mind. Similarly, you need to know what 3 squared is. 3 times 3 times 1, or just 3 times 3, is 9. You need to know what 4 squared is. 16. You need to know what 5 squared is. 25. You need to know what 6 squared is, right? 36. 7 squared, 49. 8 squared is 64, okay? And now, I want you to be able to go all the way up to 15. So let's do the rest of them up to 15, okay? 9 squared is 81. 10 squared is 100. Now, honestly, 10 you should be able to do to any power because it's just, when you do 10 to a power, it's just a 1 with that many zeros. So 10 to the 17th power would be a 1 with 17 zeros after it, okay? 11 squared is 121. 12 squared is 144. 13 squared is 169. 14 squared is 196. And then 15 squared is 225. These need to be just sort of, you just have to have these memorized, okay? So if you have to sit down with a blank piece of paper and write all 15 of the, well, really it's 14 of them, write all 14 of them out, then do that, okay? Now there is something else that you need to have in your memory continually, and that is that 1 to any power, so I'm just going to put 1 to the x power, is always equal to 1, okay? So 1 squared is equal to 1 because 1 times 1 is 1. 1 to the 47 power, if you multiply 1 by itself 47 times, that's also 1. These are all required. They just need to be in your mind continually when you're doing math. And we've already previously said that any value to the 0 power is equal to 1. So I want you to keep that in mind as well, okay? Similarly, we need to have memorized a handful of powers of power 3, okay? So to the third power. For the third power, I only require that you go up to 5. So you need to know what 2 to the third power is. Okay, so 2 to the third power, 2 times 2 times 2. We'll leave off the arbitrary times 1 for now. 2 times 2 times 2, 2 times 2 is 4, 4 times 2 is 8. 3 to the third power is 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. So 3 to the third power is 27. 4 to the third power, that's 64. You can do it for yourself. And 5 to the third power, that's 125. Now this 5 to the third power equals 125 is one of my favorite relationships in discussing what we're going to discuss today. So you're going to see 5 to the third power equals 125 several times, okay? All right, lastly, I need you to have the fourth power for only 2 numbers. I need you to know what 2 to the fourth power is, which is basically 2 to the third power times 2, right? Well, we already know that 2 to the third power is 8, and 8 times 2 is 16. So 2 to the fourth power is 16. How about 2 to the fifth power? Well, we're just going to take our 16 and multiply it by 2 again. So that would be 32, and 2 to the sixth power, 32 times 2, that's 64. And you actually should be able to do 2 to the 7th, 8th, 9th power. All we're doing is doubling this number. So 2 to the 7th is 128. 2 to the 8th power is 256. You should be able to do that. But just in your memory, I require that you know up to 2 to the 6th power. Okay? And then the last one that I want you to know is I do want you to know 3 to the 4th power. So 3 to the 4th power is 3 to the 3rd power, 27, times another 3. And that's going to be 81. Another way to think about this 3 to the 4th power goes like this. 3 times 3 times 3 times 3, right? Well, what's 3 times 3? That's 9. And what's this other 3 times 3? That's also 9, and we know that 9 times 9 is 81. And that's why 3 to the 4th power is equal to 81. We can also write 3 to the 4th power as 3 squared, okay? And so we know that in this situation, we would multiply the 2 times the 2. That would be a 4. So 3 to the 4th power is 3 squared squared. 3 squared is 9. 9 squared is 81. So there you go, okay? All right, so you need to have these basics, squares, a few of the third powers, a couple of the fourth powers, and then 1 to any power, anything to 0 power, and then 2, you should know at least up to the 6th power, okay? And so now with this knowledge in mind, I'm going to begin talking about what we call rational exponents. Okay, so let's talk about rational exponents, okay? This is the same subject as what we often call radicals. Okay, so if you know what radicals are, like the square root of, the third root of, the fourth root of, that's the same thing. This is, we represent them with what we call rational exponents. Well, you may say, well, what does this word rational mean? Well, one way of understanding, at least for today, is I'm going to write the word rational, okay? Rational. Whenever you think of the word rational, I want you to throw in a couple extra letters. I want you to put an F at the front, and I want you to squeeze in a C between the A and the T here, and what we get is fractional. And so when we say rational exponents, we actually mean fractional exponents. What we're talking about here is we're talking about taking a number like 7 and raising it to the power of a fraction, like 1/5. So 7 to the 1/5 power. Now you may say, I don't really like that very much. I don't like fractions to begin with. I don't particularly care for exponents. So to make an exponent a fraction, I don't like that very much. Okay, well, I'm going to try and make it as easy for you as possible. Just follow the pattern and you should be just fine, okay? All right, so let's go back to that exponential number that I like so much. I said I really like 5 to the third power, and I told you that 5 to the third power is equal to 125. That's 5 times 5 times 5. 5 times 5 is 25. 25 times 5 is 125. So this is a mathematical truth. We know that 5 to the power of 3 is equal to 125. Well, there's something really neat that we can do here algebraically using the rules of exponents. Let's say that I were to take this 5 to the third power, put some parentheses around it, and then I'll take the 125, put some parentheses around it, and here's what I'm going to do. I'm going to apply a 1/3 power to both sides. I'm going to raise both sides to the power of 1/3. Now, you may say that looks a little scary, but there's a really good reason that I selected 1/3. I selected 1/3 because of the power of 3 right here, okay? What should be, based on the rules of exponents, what should happen to this 3 and this 1/3? Shouldn't this become 5 to the power of 3 times 1/3? And 3 times 1/3 equals 1. 3 times 1/3 equals 1. And so this is equal to 5 to the first power, which we know equals 5. And so over here on the left side, we know that this now equals 5. And then over here, we'll have 125 to the 1/3 power. So this is another mathematical truth. If this is true, that 5 to the 3rd power equals 125, we can also say that 5 is equal to 125 to the 1/3 power. Well, this is equal to another thing that we already know in math, and that's called roots or radicals, okay? And so this can be written in this way as well. We can write 5 is equal to what's called the cubed root of 125, okay? And so if 5 is equal to 125 to the 1/3 power, and 5 is also equal to the cube root of 125, then that must mean that these two mathematical statements are equivalent. That the 3rd root of 125 is just another way of writing 125 to the 1/3 power. Now, let's work with something that you may be a little more familiar with, and we'll do the exact same thing. You know that 3 squared is equal to 9, right? Well, if we do the same thing here, if we take this 3 to the 2nd power and raise it to the 1/2 power, and do the same thing to the 9, raise it to the 1/2 power, this becomes 3 to the power of 2 times 1/2, which equals 1. This is 3 to the 1st power, which is also 3. And so we can say, if this equals 3, we can say that 3 is equal to 9 to the 1/2 power. But we also know that this 9 to the 1/2 power, we know that 3 is also equal to the square root of 9. That the square root of 9 is equal to 3. Well, if 3 is equal to 9 to the 1/2 power and 3 is equal to the square root of 9, then we know that the square root of 9 is the same thing as 9 to the 1/2 power. And so why don't you write this down? I'm gonna show you something that you can write down. Is very simply, I'm just going to give you a few of them. Anytime you see square root of something, that's the same thing as to the 1/2 power. Okay? If you see the cubed root of something, that's the same thing as to the 1/3 power. If you see the 4th root of something, that's to the 1/4 power. Okay? And so basically, what's happening here is we're saying that if you have a something root, so let's put like the letter K here. If you have the K root of anything, that's the same thing as saying to the 1/K power. And so now, all you need to do right now, we're going to take this a little bit further, is I just want you to be able to convert something that looks like this, okay, or I'm sorry, I want you to convert something that looks like this, a radical, I want you to convert it into a rational exponent, and if it's a rational exponent, I want you to be able to convert it into a radical. That's mainly all I want you to be able to do at first in this class. So why don't we do a few examples of that? It's really, really simple. Why don't you do them along with me? If I gave you the square root of 91, how could we write this? Instead of with a radical symbol, we're going to write the number 91 and we're going to give it a power that's a fraction. Okay? Well, over here it says that the square root symbol means to the 1/2 power. So the square root of 91 is the same thing as 91 just to the 1/2 power. It means the exact same thing. Okay? All right. So what if I wanted to do the 5th root of, let's say, 17? The 5th root of 17. okay, well, I don't see fifth root over here. But look, this does say that if I have a root symbol and I have some kind of number here, whatever the number is, so let's pretend the k is a 5, okay? So then that would mean to the 1 over 5 power. So that means we just need to do 17 to the 1/5 power, okay? And that's pretty much it. Now, I do want you to go one step further. Well, actually, I forgot. Let's do the opposite. Let's say that I gave you, I don't know, 35 to the 1/4 power, okay? I now want you to write this as a radical, okay? So, well, the 1/4 power means that you want to use this symbol right here. It's the like the square root symbol with a little 4 shoved in there. We're going to write that thing. We're going to write the square root symbol, but we're going to shove a 4 in there. So instead of it being the square root, it's the 4th root, and it's the number 35. The base is 35, and so 35 to the 1/4 power is the same thing as the 4th root of 35, okay? All right, there's only one more thing I want you to be able to do with this particular skill, at least for now, and that is I want you to be able to take your memorized squares, cubes, 4th powers, and 5th powers, and I want you to be able to solve them. So if I gave you something like this, if I gave you the 32 to the 1/5 power, I would want you to be able to turn this into the 5th root of 32. And then the question is this, is what is this asking? This is asking what number times itself 5 times equals 32. Some number to the 5th power equals 32. Well, I made you memorize this at the beginning of this video, didn't I? I told you had to memorize this. I said there's a truth, a mathematical truth that says a number to the 5th power is equal to 32. Well, we know that that's 2 to the 5th power is equal to 32. And therefore, the 32 to the 1/5 power is equal to 2, okay? And we know that this is true because if we take this thing and raise them both to the 5th power, 1/5 times 5 is 1, and so 32 is equal to 2 to the 5th power. Well, we know this is true, and therefore the answer to this question is just simply 2. That's it. It's just 2. 32 to the 1/5 power, or the 5th root of 32, is equal to, oh, I'm sorry, this is wrong. I shouldn't have put an equal sign here. I should have put an arrow like that. Sorry about that. This is equal to 2, okay? Let's do maybe one more example like this. What if I were to ask you, what is 81 to the 1/4 power? Okay, so what number times itself 4 times is equal to 81? Well, we know that the answer to that is 3, because 3 to the 4th power is equal to 81. Therefore, we can write this as the 4th root of 81, and the 4th root of 81 is equal to 3, because we know that 3 to the 4th power is equal to 81. Okay? All right, so that's all I want you to be able to do at first with these rational exponents, and in the next video, we'll continue with some more exponential skills.